Welcome to chemistry classes. In this video, we are going to discuss about phosphorus and its compound. P block elements. We are going to discuss here third part of P block elements, and here we have to discuss phosphorus and its compounds. Phosphorus and its compound. First, here we have to understand different type of allotropes, different allotropes of phosphorus. Red phosphorus, white phosphorus, black phosphorus, these are the different allotropes of phosphorus. Okay, white phosphorus, red phosphorus, black phosphorus, these are the different allotropes of phosphorus. First, we have to understand more details about white phosphorus. White phosphorus, it is waxy solid, white colored waxy solid. White phosphorus, it is insoluble in water, but it will dissolve in carbon disulfide. It will dissolve in organic solvents such as carbon disulfide, CS2. Okay, and white phosphorus, it glow in dark. White phosphorus, it will glow in dark. This property called chemiluminescence. Chemiluminescence. This property called chemiluminescence. Clear? And here another one, white phosphorus, it will dissolve in boiling sodium hydroxide. White phosphorus, it will dissolve in boiling sodium hydroxide and it will produce phosphine. Look here, white phosphorus dissolved in boiling sodium hydroxide and it produced phosphine. Phosphine means pH3, that is phosphine. Clear? So here in this slide we discussed here phosphorus, allotropes of phosphorus. White phosphorus, red phosphorus, black phosphorus are the allotropes of phosphorus, and we discussed different properties of white phosphorus. White phosphorus, it is white waxy solid. Also white phosphorus, it is translucent. It is translucent material. Okay, then here we discuss white phosphorus, it is poisonous substance and insoluble in water. It is poisonous, insoluble in water but dissolved in carbon disulfide. White phosphorus, it glow in dark. This property called chemiluminescence. White phosphorus, it dissolved in boiling sodium hydroxide and it produced phosphine. Phosphine means pH3. Phosphine. Okay, next one we have to understand here white phosphorus, it is highly reactive and less soluble in water. Highly reactive and less soluble in water because of its angular strain. You can see here the diagram for white phosphorus. Okay, here the bond angle, it is 60 degree or bond angle is less. Because of this less bond angle, they have high angular strain. Okay, that's why this white phosphorus highly reactive and less soluble in water. Clear? Then here next point we have to understand here white phosphorus on strong heating. After strong heating in an inert atmosphere at 573 Kelvin, white phosphorus will turn to red phosphorus. Again red phosphorus after strong heating at very high pressure, it will turn to black phosphorus. Okay. So white phosphorus after strong heating, it will turn to red phosphorus. Red phosphorus again after strong heating, it will turn to black phosphorus. Okay, here red phosphorus possesses iron gray luster. Red phosphorus, it possesses iron gray luster. It produces this type of color, iron gray luster. Also red phosphorus, it shows polymer structure. It will form polymer structure. Okay, you can see here diagram here the polymer structure of red phosphorus. So these are the different points we discussed here. White phosphorus, it is less soluble in water and highly reactive because of its angular strain, less bond angle, angular strain. And red phosphorus is obtained by heating white phosphorus more than 500 Kelvin in an inert atmosphere for several days. We have to heat it several days. Then this white phosphorus turns to red phosphorus. Again, red phosphorus, after strong heating at very high pressure, it will turns to black phosphorus. Red phosphorus, it possesses iron gray luster. Similarly, here red phosphorus, it forms polymer structure. Compared to white phosphorus, red phosphorus, it is less reactive. It is less reactive and it do not glow in dark. We discussed white phosphorus, it will glow in dark, but red phosphorus, it do not glow in dark. Okay, next one, we have to understand here important compounds of phosphorus. Important compounds of phosphorus. First one, we have to understand here PCl3. There are two important compounds we have to understand here, PCl3 and PCl5. PCl3 and PCl5. PCl3 means phosphorus trichloride. First, we have to discuss here phosphorus trichloride. Preparation of phosphorus trichloride. There are two methods to prepare PCl3. First one, dry chlorine gas passing through white phosphorus. Dry chlorine gas passing through white phosphorus, we will obtain PCl3. Look here. This is white phosphorus and dry chlorine gas, both of them reacted together, it produce PCl3. Second method to produce PCl3, thionyl chloride, SOCl2, thionyl chloride. This is thionyl chloride. Thionyl chloride reacted with white phosphorus, we will obtain PCl3. Look here, white phosphorus reacted with SOCl2, it produce PCl3, and this will be the side product. Okay, so these are the two methods to prepare PCl3, phosphorus trichloride. Okay, next one, we have to understand here important compounds of phosphorus. Important compounds of phosphorus. First one, we have to understand here PCl3. There are two important compounds we have to understand here, PCl3 and PCl5. PCl3 and PCl5. PCl3 means phosphorus trichloride. First, we have to discuss here phosphorus trichloride. Preparation of phosphorus trichloride. There are two methods to prepare PCl3. First one, dry chlorine gas passing through white phosphorus. Dry chlorine gas passing through white phosphorus, we will obtain PCl3. Look here, this is white phosphorus and dry chlorine gas, both of them reacted together, it produce PCl3. Second method to produce PCl3, thionyl chloride, SOCl2, thionyl chloride. This is thionyl chloride. Thionyl chloride reacted with white phosphorus, we will obtain PCl3. Look here, white phosphorus reacted with SOCl2, it produce PCl3, and this will be the side product. Okay, so these are the two methods to prepare PCl3, phosphorus trichloride. Next one, we have to understand here different properties of PCl3, different properties of phosphorus trichloride. First, we have to understand here phosphorus trichloride. It is colorless oily liquid. Phosphorus trichloride, it is colorless oily liquid. It will react with the moisture and form H3PO3, phosphorus acid. PCl3, it will react with moisture, it produce H3PO3. Look here, PCl3, it reacting with water, it form H3PO3, phosphorus acid. Similarly here PCl3, it will react with organic compound. PCl3, it will react with organic compound, especially organic compound which contain functional group OH. Okay, the organic compound which contain functional group OH. For example, organic compound carboxylic acid, alcohol, this type of compound which contain OH. Okay, so PCl3, it will react this type of organic compound and form different type of compounds. See here example, PCl3, it will react with carboxylic acid, it produce CH3COCl, carbonyl chloride. This type of compounds are called carbonyl chloride. Okay, so here PCl3, it will react with carboxylic acid and form COCl, CH3COCl, carbonyl chloride. Similarly here carboxylic acid, it will react PCl3, it will react with the alcohol, the compound which contain OH, it is alcohol. The compound which contain OH, similarly here PCl3, it will react with the alcohol, it form alkyl halide. Here C2H5Cl, this type of compounds are called alkyl halide. Okay, and you will study more details about this type of reaction in organic chemistry. Here you just understand PCl3, it will react with organic compound which contain OH group. Example, PCl3, it will react with the carboxylic acid, it form carbonyl chloride. PCl3, it will react with alcohol, it produce alkyl halide. Okay. Next one we have to understand here, this is the structure of PCl3. Okay, PCl3, it is pyramidal structure. PCl3, it is pyramidal structure. Okay, and here phosphorus. In PCl3, phosphorus is sp3 hybridized. Okay, so here PCl3, it is pyramidal structure. In PCl3, phosphorus is sp3 hybridized. Okay. Okay, next one we have to understand here PCl5, phosphorus pentachloride. Preparation of phosphorus pentachloride. Here we discuss PCl3, preparation of PCl3. Similarly here white phosphorus react with excess chlorine, it form phosphorus pentachloride. White phosphorus react with excess chlorine, it produce PCl5. Similarly, another method to prepare PCl5, white phosphorus react with SO2Cl2. Phosphorus pentachloride, another method. Here white phosphorus reacted with thionyl chloride, SO2Cl2, thionyl chloride, it produce PCl5. So these are the two methods to prepare PCl5. First one here P4 reacting with excess Cl2, it produce PCl5. Second method here P4 reacting with SO2Cl2. SO2Cl2 means thionyl chloride. White phosphorus reacted with thionyl chloride, it produce phosphorus pentachloride. Clear? After that we have to understand here different properties of phosphorus pentachloride. Phosphorus pentachloride, it is yellowish white powder. Also it will hydrolyze. PCl5 hydrolyze in moisture and produce H3PO4. We discussed before PCl3. PCl3, it is colorless liquid, and after hydrolysis in moisture, it produces H3PO3, phosphorus acid. But here PCl5, it will hydrolyze in moisture and it produces H3PO3. The previous one H3PO3, now it is H3PO4. Phosphoric acid, phosphorus acid. This is phosphorus acid, this is phosphoric acid. Clear? And here this is oily liquid and here this is PCl5 yellowish white powder. Clear? So these are the points we have to understand here. PCl5, two methods to prepare PCl5, and also we discuss here two properties of PCl5. Okay, next one, another property of PCl5. PCl5 on strong heating it will decompose. PCl5 after strong heating it will decompose to PCl3 and PCl3 and Cl2. But at normal heating it will sublime. PCl5 on normal heating, after heating it will sublimize. PCl5 it is yellowish solid state, it will change to gaseous state after heating. But after strong heating it will change, it will decompose. PCl5 it will change to PCl3 and chlorine. We discussed PCl3 it will react with organic compound. Similar way PCl5 also react with organic compound which contain OH functional group. Look here, the compound which contain OH functional group, carboxylic acid and alcohol. PCl5 react with alcohol, it form alkyl halide. We discussed same way we discussed in PCl3, alcohol reacted with PCl3, alkyl halide formed. Similar way, alcohol reacted with PCl5 also alkyl halide formed with side product POCl3 and HCl. Also here PCl5 react with carboxylic acid, it form carbonyl chloride. Carbonyl chloride means CH3COCl, carbonyl chloride plus POCl3 and HCl. Okay, so these are the chemical reaction. This is the chemical reactions of PCl5 with organic compound which contain OH functional group. Okay, and also here fine powdered metal. Fine powdered metal it will react with the PCl5, it form corresponding chloride. Example here, powdered silver reacted with PCl5, it forms silver chloride and PCl3. Fine powdered tin is a metal, fine powdered tin reacted with PCl5, it forms tin chloride with PCl3. Okay, so here we discuss on heating PCl5 it will sublimize, it will change to gaseous state, but after strong heating PCl5 decompose to PCl3 and chlorine. Okay, and PCl5 react with organic compound which contain OH functional group. Example, alcohol and carboxylic acid, it form alkyl halide and carbonyl chloride. PCl5 it react with the fine powdered metal and form corresponding chloride. Reacted with the silver, form silver chloride. Reacted with the tin, it form tin chloride. Clear? Okay, next part we have to discuss here. In gaseous and liquid state, PCl5 exists as a pyramidal shape. Okay, in gaseous and liquid state, PCl5 in pyramidal structure. This is the pyramidal structure, trigonal bipyramidal. Okay, and here gaseous and liquid state PCl5 in this form. But in solid state PCl5 exists as ionic compound. Look here PCl4, PCl6. That is similar to 2PCl5, 2 phosphorus and 10 chlorine. Okay, so here in solid state PCl5 exists in the form of ionic compound. You know, ionic compound there is positive and negatively charged ions. Okay, and here this positive part, it is tetrahedral structure. Positively charged part, it is tetrahedral structure, and negatively charged part, it is octahedral structure. Okay, so these are the things we have to understand here. Gaseous and liquid state, it is pyramidal structure, and solid state ionic compound, and this is the ionic compound, this is the ionic part of PCl5. Okay, and here remember PCl4 positive, PCl6 negative charge, and tetrahedral, here this is tetrahedral and this is octahedral. Okay, so these are the things you have to understand about PCl5. Okay, next one we have to understand here oxo acids of phosphorus. Phosphorus forms different type of oxo acids. You can see this table. In this table you can see different oxo acids of phosphorus. Okay, here the formula, you can see their name, formula, and their oxidation state, etc. So here oxo acid, all the oxo acid which contain phosphorus double bond oxygen, all the oxo acids of phosphorus which contain phosphorus double bond oxygen, also which contain phosphorus single bond OH. This bond, phosphorus double bond oxygen, phosphorus single bond oxygen, you can see in all oxo acids of phosphorus. Okay, and here orthophosphorus acid mean H3PO3. Okay, that is orthophosphorus acid. Orthophosphorus acid, on strong heating disproportionation takes place. After that it form phosphoric acid and phosphine. Disproportionation reaction means chemical reaction in which both oxidation and reduction takes place. So here orthophosphorus acid, on strong heating disproportionation takes place and the product will be phosphoric acid and phosphine. Clear? Here oxo acids which contain P single bond hydrogen, phosphorus single bond hydrogen, they have strong reducing power. Orthophosphoric acid or oxo acids of phosphorus which contain phosphorus single bond hydrogen, they act as strong reducing agent. Example for this, hypophosphorus acid. You can see the structure, hypophosphorus acid which contain 2 phosphorus single bond hydrogen. It contains 2 phosphorus single bond hydrogen and it acts as strong reducing agent. Okay, so here we discuss different type of oxo acids of phosphorus. All the oxo acids of phosphorus which contain phosphorus double bond oxygen, phosphorus single bond OH bond. Okay, and orthophosphorus acid, on heating disproportionation takes place and form phosphoric acid and phosphine. Oxo acids of phosphorus which contain phosphorus single bond hydrogen, they have strong reducing power. Example for such type of acid, hypophosphorus acid which contain 2 phosphorus single bond hydrogen and they have highest reducing power. Okay, so these are the things we have to discuss in this video. In this video we discuss phosphorus, allotropes of phosphorus, different phosphorus compounds and their preparation and properties. Okay, so rest of the part we will discuss next video. Okay, so thank you for watching.